Hello everyone, my name is Ankit Nanwal and I am teaching you engineering mechanics. The topic for today is resolution of forces. So what is resolution of forces? Resolution of forces means it is the process that divides the resultant force into two different components. And what are those components? These two components are the special components that are rectangular components. The name for those components is rectangular components. So why we call them as rectangular components? And how we divide the resolution of forces or how we divide the resultant force into two different components. So I will be telling you in this lecture. So the topic is resolution of forces. Before that, I have told you in previous lecture about the vectors. The vector is the physical quantity that is having a magnitude as well as direction. Its example of that was force. Suppose this is a body kept on the surface and you are trying to pull this body with a force 10 Newton. So this force that you are applying is having a of 10 magnitude of 10 Newton, and you are applying the force in this direction. It is having magnitude also and direction also. Therefore this type of quantity is known as vector quantities. Okay, and the vector quantities and the physical quantities which have magnitude as well as direction and obeys the triangle law of vector addition. So what is triangle law of vector addition? Triangle law of vector addition says if the vector, this is vector A in this direction and this is vector B in this direction, then the resultant force of these two vectors will be this. This is given by r vector equal to A vector plus B vector. I hope you have studied triangle law of vector addition and parallelogram of vector addition in vectors in your schooling, during your schooling time in 12th or 11th. Okay, so this is the triangle law of vector addition. So now we will be starting with resolution of forces. Resolution of forces means it is the process when resultant is divided into two components. When the resultant force, suppose you are having one force, this F force in one direction, and you need to know the force in this direction and this direction. So how will you dividing this force in this direction and this direction? We have to divide this resultant force in these two directions. How will you divide it? We will be explaining with the help of one example. Suppose this is the river and here is one boat. Now this boat is not having an oar. Oar means OAR. The oar means this stick which this man is having in his hand. I hope you are able to see this stick the man having in his hand with the help of which he is trying to move the boat forward. So in this boat the oar is missing. In Hindi it is called chappu. Okay. So now you are, suppose you are sitting in this boat and you want to move the boat in this direction and you are not having oar. So how will you move the boat? Suppose now you are having two ropes here. So what you will do? Suppose one of your friend is sitting here and one of your friend is sitting here. You will give one rope to this friend and one rope to this friend. Okay. Now you will ask them to pull the rope in their direction. So this friend will be having different power, so he will pull the rope with some force, and he will be having different power, so he will pull with this force. Okay, so this force will be different and this force will be different. Okay, suppose I am denoting it by Fa and this one is Fb. Okay, now when they will pull the rope in this direction, he will move the rope in this direction, he will move the rope in this direction, and as they both are moving the rope in their direction, this boat will try to move forward with the magnitude of force F. So this magnitude comes from these two components. So we need to divide this resultant force into two components. So how will you divide this resultant force? We divide this resultant force, there is a simple concept that the component that is having an angle theta with the resultant force. Suppose FB, this is B body, second body is having an angle theta with the resultant force. So this component will be resultant force dot the cos theta. So this component is cos component and the other component is sin component. So F dot sin theta. Okay. So I hope you are clear how to resolve the resultant force. So this is the resultant force and this component is having an angle theta with resultant force. So this component is cos component and other component will automatically be sin component. And it is not that we can only make two components. You can make several components. Suppose you are having um, two more ropes, so you are giving to one friend here and one friend here. Then combination of four components will be given by result, will give you resultant force in this direction. Okay, when this is 1, this is 2, this is 3 and this is 4, they now 4 people are applying force to move the boat in this direction. Okay, so it will be having more magnitude, but we are only concerned with the special component. That special components are known as rectangular components. Now why we call them as rectangular components? Because these two components make an angle 90-degree with themselves. Suppose this is angle, this is B and this is A. These both component is having an angle 90-degree with them. They are having 90-degree to, they are at 90-degree to each other. So they try to make a form of a rectangular, so we call them as a rectangular component. These are the special component. We are only concerned with these component because they give the maximum resultant force. With the help of these rectangular component, we give the maximum resultant force. Okay. So I hope you all are clear with the concept of resolution of forces. So how we divide the resultant force into component and how the component force can be get into resultant force with the help of triangle law. Okay, the vectors obey the addition of vector, obeys the triangle law of vector addition. Okay, the vector quantities obeys the triangle law of vector addition. Okay, so now there is the definition of rectangular components. So rectangular, what are rectangular components? I have already told that rectangular components of given force are two components such that they are perpendicular to each other. They are at 90-degree to each other. Resultant of these two will give the resultant force. The resultant of these two will give resultant force. Okay. So this is how we calculate the resultant force. Now let us see some numerical part, that how we divide this resultant force into components. Suppose this is a force F is given as 10 Newton and it is at an angle 30-degree with the horizontal. Now we have to divide, or we have to calculate the rectangular forces. Now how will you calculate the rectangular components? Sorry. Now I have already told the component that is having a angle with the resultant force is the cos component. So here this component will be given by F cos theta and the other component will be given as F dot sin theta. So now simply put the values of force is 10 Newton. So put the value 10 and cos theta is cos 30-degree. So angle is 30-degree. So put the values and you will get the values as this. Kindly check with your calculator if this is correct or not. Here also put the value, is given as 10 sin theta, sin 30. So put the values and calculate the values. Okay, so this is how you calculate. Now let us see the second one that says here, suppose it is given that this is the horizontal surface, it is a inclined surface here, it is at 45 degree with the horizontal, and here is one force that is applied here, that is F equals to 10 Newton at an angle 10 degree with the inclined surface. Now you have to calculate the rectangular components of this force. How will you calculate? Simply, first of all, you will make a Cartesian system here. Now you have made the Cartesian system. Now simply provide the, suppose this is A and this is B, okay. Now the angle here is 45 degree. So the angle that total will be making, this total angle, this and this total angle will be 45 degree as it is an alternate angle. So as this angle total is 45 degree and this is 10 degree, the remaining angle will be 35 degree. So the component that is having an angle with the resultant force will be given by, it is cos component, so F cos 35 degree, and this component will be F dot sin 35 degree. So this is how you resolve the forces component. Simply put the values and calculate the answers. Okay, this is very simple. There are some special forces that you must know about, that are weight, mass and normal reactions. Okay, so what is the weight? It is the gravitational force acting on the body. Suppose this is a body that is kept on a surface, it is having a mass m. Okay, now it is kept on this body, so therefore gravitational force must be acting here, so weight of the body will be acting downward, that is given by mass into gravity. So weight is the gravitational force acting on the body, it is given by, or it is unit is Newton. Okay, it is given by W. It always acts vertically downward, this is very important, it always acts vertically downward. Now what is mass? Mass that tells how many particles are there in the body. What is the mass? Mass is that quantity that tells how many particles are there in this body, is known as mass. Mass tells us how many particles are there in the body. Its unit is kg. Okay, its unit is kg. Now the other force, that is normal reaction. It is the reaction which is given by the surface on any body, that I have once told you, that suppose this body is kept here, it is kept in this surface, as it is having mass m, and its weight will be acting downward, that is given by W, that is mg. Okay, now who is balancing this weight? The normal reaction force that is balancing that force, that is given by N, and it is always perpendicular to the surface. It is always perpendicular to the surface. Okay, it is always perpendicular to the surface. This is 90 degree. Now it is the reaction which is given by the surface on any body. This is the reaction that is given by this surface on the body, comes in contact with it, by which this body is in contact with. Okay, it always acts perpendicular to the surface, that I have already told. If the surface is inclined also, if it is flat also, the normal reaction force will always be perpendicular to the surface, either it is inclined or flat. Now the last one, that is frictional force. Now frictional force is, suppose this is an object here. Now you are pulling this object by an force F. So this surface will resist its movement this side. So it will apply the force in this direction. That opposite force, that opposite force in the opposite direction of the applied force is known as frictional force. It is always opposite to the direction of the applied force or applied motion. Okay, either the surface is inclined or either the surface is flat. Okay, suppose the surface here is inclined, this body is kept here, the weight will be acting downward, normal reaction force will be acting upwards, always perpendicular to the surface. Now if the motion is in this direction, if it is body is going this way, so frictional force will be acting in opposite direction. So this part, these are the special three forces you must know about, that are weight and normal reaction and frictional force. So for now, for today's lecture, this much is sufficient. So I hope you all are clear with the how to divide the resultant force into two different components, and we are only concerned with the special component. And you try to do the numerical part of resolution of forces. For now, thank you very much.